Hi viewers, in this video we will solve problem 1.13 from the book Heat Transfer J.P. Holman 10th editions. Two very large parallel planes having surface conditions that nearly approximate those of a black body are maintained at 1100 and 425 centigrade respectively. Calculate the heat transfer by radiations between the planes per unit time and per unit surface area. So let's say we have two planes, that is one at a temperatures of 1100 centigrade and the other plane that is at a temperatures of 425 centigrade. So between them the heat transfer is taken place through radiations, and we need to find that heat transfer per unit area. So heat transfer per unit area is our requirement to find temperature T1, that is 1100 at 273, whether to convert into Kelvin, that is 1373 Kelvin, and the temperature T2, that is 425 centigrade plus 273, so it will become 698 Kelvin. Stephen Boltzmann constant, that is 5.66 multiplied by 10 to the power minus 8. So from from the Stephen Boltzmann radiations law, heat transfer per unit area is equal to Stephen Boltzmann constant and for power of the absolute temperatures. So there is two temperature, we need to find its difference, T1 to the power of 4, T2 to the power 4. Now heat transfer per unit area is our requirement, 5.66 multiplied by 10 to the power minus 8. What is T1? That is 1373 power 4 minus 698 to the power 4. So after simplification this on the calculator, you will get the heat transfer per unit area. You will get that is 188 kilowatt per meter square, and this is our final answer. I hope you understand. If still you have any confusion, you can ask in the comment sections. Please subscribe my channel for more such videos. Thank you so much.